Fortune 500 companies trust Interoptic for optical transceivers and cables. Since 2004, Interoptic has provided high-performance optics and cables at a fraction of the cost of OEM gear. Interoptic products are 100% tested and backed up by real engineers. Work with the optics experts at Interoptic. Find out more at interoptic.com/packetpushers.
Welcome to Heavy Networking. We are diving into a solution our guest built to support BGP Monitoring Protocol at ISP scale. BGP Monitoring Protocol, or BMP, is defined in the IETF's RFC 7854. Now, what's BMP do? Well, here's a paraphrase from RFC 7854's intro section. BMP provides access to the table of BGP announcements received from a BGP peer before the receiving router has done any filtering. BMP also sends other statistics a BMP monitoring station can analyze. Our guest is Bart Dorlandt, a network automation solutions architect based out of the Netherlands. I am Ethan Banks, and with me is Drew Conway Murray, your co-host for this BMP-focused episode. You can connect with Drew and me on LinkedIn, Blue Sky, and the Packet Pushers audience Slack channel, which you can join at packetpushers.net/community. And by the way, if you've not connected with Blue Sky, it is open to anybody now, and the tech community has had a massive influx here recently as Drew and I are recording this. Drew was there before it was cool, when it was invite only, and I just joined up recently, finally joined the zeitgeist over at Blue Sky, and lots of other technologists have made the move. So come on over to Blue Sky if you're looking for tech community. Lots going on there. In our conversation today with Bart, we are going to discuss what BMP is good for, how Bart needed to use BMP, the implementation challenges he ran into at ISP scale, and then how he conquered them. So Bart, welcome to Heavy Networking. This is your first time on the podcast network, as far as I know. Is that right, Bart? I don't think you've been on before, have you?
Well, actually, I had a 5-minute coffee break session with you when I was over at NetIce.
Oh, okay. So that goes back a ways. Yeah. All right.
Yes, that's a few years.
Okay.
Yep.
Well, these days you're not at NetIce, so why don't you tell people who you are and what you do?
Yeah, sure. So, hi again. Thanks for having me. My name is Bart Dorlandt. I'm a self-employed network automation enthusiast, though the NASA sounds right if you make it an acronym, right? The Network Automation Solution Architect. But yeah, coming from networking background, and just love it these days all the way up to software development.
Okay, so you're a nerd who's been involved in automation for a while. I mean, back in the days when you were working with NetIce, that's of course the network automation platform, still around today. And now you just do it. Now you just do it yourself, as an independent person. Yes. You've been doing it for a long time. Okay, so BMP is our subject today. Bart, you brought this project to us that you'd done. We should start by defining BGP Monitoring Protocol, or BMP, for folks. Yeah, I mentioned RFC 7854, but forget that and just tell us in your own words what BMP is all about.
Yeah, sure. So I'd like to compare it to a route reflector, right? And the people familiar with BMP, or BGP, they know the route reflector, right, for the iBGP sessions, to make less of them, essentially, and have everything reflected through that. This essentially does the same thing, where it takes all the updates and the withdraws from BGP, essentially everything that's coming in, copies that over to using the BMP protocol, and send that to a station or a collector, right? Essentially a service where it can push that information to. So the good thing with that is it's sending the data, right? Let's straight get to the good points. So that's the major benefit. It actually pushes the data from the router towards the station, instead of having a pull model where you have an interval and scraping and therefore delays with that, right? And you might miss information because of that. While with this push model, you will get all the updates, essentially.
It's a form of, I guess we could call it BGP telemetry. I mean, you're seeing all of the route updates that are there. It's, as I understand it, I think this is an important point that's going to come up later in our story today, but BMP is showing you the ADJ rib in table. That is before any policy filtering has happened. So you're seeing everything that a peer sends you, right?
Yeah, so that's configurable, but essentially one of the big features is indeed that pre-policy data is viewable, right? You can monitor that as well as post policy, or just having the routing table, essentially. But the pre and post is where you can get the most power from BMP.
So-
if you could make a distinction between, like, someone could maybe argue, hey, I kind of get all this data with a looking glass. I just have a BGP peer and pull everything from BGP that way to do my analysis work. But this is different. It's not a BGP peer exactly, but it's similar. But there's a BMP station and a collector. So what's the distinction there? Why would I use BMP and not just go the looking glass approach?
So depending on what you're looking for, right? So with the looking glass approach, you will get everything post policy, so after filtering. Therefore, you would have everything that is accepted into the BGP table, which you would normally look at, right? Which is also used to eventually get to the actual routing table. Though, therefore, because of that, and because you only get that post policy data, you're missing out on what could have been filtered or what could have gone wrong and therefore not accepting a route, right? Whether you have community filtering or anything essentially in your filter, if you don't see the pre-policy, you can only see what's accepted into the BGP table essentially, right? And therefore with BMP, you could choose to get the pre-policy data, pick out everything, seeing also therefore, hey, I'm getting 10,000 routes on the pre-policy, while post-policy I only get 8,000, and you now have a chance to look at that in a better way than just doing it on the CLI, essentially.
So it sounds like you're sort of getting to this next question, but so what are my use cases for BMP? Why do I want to set this up?
I would say the main use case is being able to see why certain prefixes didn't end up in the routing table or in the BGP table, right? And normally you would have to go like, hey, I'm expecting certain prefixes from this peer, and you would, or a NOC engineer or an engineer of any kind would look at the device, at the router, and go in and see, okay, well, actually, let me see what prefixes I learned pre-policy on the CLI and doing it the same on post-policy and figuring out why it's missing, right? It will tell you like, hey, this prefix is not accepted because of reason ABC. Now, with this solution, you don't have to go to the CLI. You can do that offline, essentially.
Uh-huh.
Okay, so because all the data is being exported off of the different BGP routers that you care about paying attention to here, you don't have to interact with those routers directly to pull that data. BMP is getting into a collector, and then you're able to munge it, see all that data in an offline way, essentially.
Yes, correct. So, correct.
Okay. So I guess this gets to, so BGP is, I think the RFC was codified in 2016 sometime, whenever. So it's been around a while, but not super long. What would we have done before BMP existed to gather this? I mean, you mentioned screen scraping. Is that the best we could do?
Yeah, and the worst, right? It's it goes hand in hand. But yeah, it's been out there a while, and indeed, what would you have done before that, or even if this solution might have been too complicated, right? And you just wanted to see on the occasion, and you would go into looking, hey, we got an issue with this peer. Let me dive in specifically, right? And that would work, right? You could take your NetMiko or equivalent library out there and write something about it, and doing a pre-policy command and a post-policy command specifically for those prefixes, do a diff on that, and you would figure out what's going on, right?
But that's also really taxing on the router. I mean, the router's got to cough all that information up, and if you've got a massive set of prefixes in there, especially if you're an ISP working with full internet tables, that's just seems heavy.
It is, right? And that's together with that. So yes, for a single peer, right, you're allowed to do that. You got approval for that, right? But if you're gonna do that continuously, let's say every 5 minutes, and you got thousands of customers connected one way or another, and you have to go through each of those peers, because there is no command on a router to give me everything pre-policy for all the peers, right? There's no such thing where you can get a digest of everything. You have to do it on a per neighbor basis, on a per peer basis, essentially, and go through that pre and post policy commands.
Yeah. Well, there's some commercial tools out there. Do they deal with pre and post in any way?
So a lot of them are looking, and as you mentioned, are from kind of the looking glass perspective, right? They would set up a BGP session, and data would get reflected to that over that session, essentially, and you would get all the post policy data, right? And you would be able to get graphs and information from that, right? And that can hold very useful information on statistics, and if peers went down or up, or they started advertising and therefore also accepting more prefixes than previously, and you would get a lot of data from it, though you would still be missing out the pre-policy data.
Okay.
Let's pause for a message from our sponsor, Interoptic. Interoptic is the optical transceiver and cable specialist that maximizes your IT savings while minimizing network failures. Interoptic provides high-performing optics at a fraction of the price of brand-name optics. The Interoptic experts can help you spec the best optical transceivers and cables for your network environment. Interoptic optical transceivers are 100% guaranteed to be operationally equivalent with Cisco, Juniper, Extreme, Arista, Brocade, Palo Alto, and many other switches and routers. Due to Interoptic's deep optical transceiver technical experience, they can ensure that all messages, alerts, alarms, and threshold data are equivalent to OEM brands. Interoptic deploys rigorous 100% testing on their devices before they're shipped. Interoptic optical transceivers are built to the exact same quality standards as the OEMs and typically come from the exact same manufacturing lines. That's why insurance companies, retailers, financial services, and federal and state government customers deploy optics and cables from Interoptic. You can purchase the same, if not better performing optical transceivers, tested and backed up by real engineers at a fraction of OEM costs. Find out more at interoptic.com/packetpushers. That's interoptic.com/packetpushers. And now back to the podcast. So it sounds like you had a very particular use case for BMP. Can you tell us what the project was?
Sure. So we wanted to be able to present this data in the portal towards the customers, right? Therefore, not only saying, hey, your peer is up, right, and it should be fine. No, we wanted to go one level deeper and saying, okay, well, actually, you're set. You're supposed to advertise 3 prefixes because that's where you want the service on, and we can now see that on the pre-policy data as well as the post-policy data, and because of that, we can also give information back to the customer via the portal, right? Like a self-service portal, where you could say, "Hey, I'm advertising this. I see my peers up. That's fine. I'm expecting to see 3 prefixes on the remote side, which I can now do that without interacting with the NOC or whatsoever. Just seeing that all light screen, or there might even be data like, well, actually, our pre-policy is showing that you're sending 3 prefixes, but only 1 is allowed through, right? Which could mean that there's a community, or there might be a setting, or there might something that we see on those things that is not allowed in our policy, right? Because in the end, our side still has a policy that is making sure that the customer is behaving, right? Because sure, we got a contract, sure, there's a certain amount of trust, but it's still BGP.
Okay, so you had a customer or a handful of customers who needed to verify BGP configurations pre-policy, and BMP was the way to do this?
So there were feature requests around that, and not necessarily that there was a hard request for having the pre-policy data, but at the same time, we thought of, hey, if we're going to do this, let's not do it via screen scraping continuously over all the peers of all the customers, but let's do it right. And if BMP, which existed, which is available on the routers, why not use this and go the extra mile to be able to give this additional feedback to the customer, where as a bonus, there is no NOC engineer required anymore to have an interaction with the customer like, hey, yeah, I'm seeing everything fine, everything is green now, you're good to go, right? Therefore, saving also time on that side.
Okay, they can just go to a portal and look for this information as opposed to having to make a call or put in a ticket.
Yeah, so the portal was already there. So this is just an addition to that, right?
Mm-hmm.
An additional feature where they can now self-verify that whatever they provided in the portal and where they said, well, I'm sending these prefixes, we can now show the green lights all the way, showing that everything is fine.
Is BMP a pretty light lift for the router compared to screen scraping?
Yes. Yeah. So on a detailed level, we're working with Junipers. There's even a setting on there where you can set the priority of the protocol, which in my test didn't have any effect. But the impact on the overall router was like an MB of resource.
Mm-hmm.
Additionally to just running there. I mean, there's a very, very tiny little spike in the beginning when it needs to process all of the BGP data, but especially after that, it's like there's no feature enabled additionally.
Okay, so you've got Juniper routers. They can send BMP. They've got to go to somewhere. So was there an open source package you wanted to use? What tools did you consider?
So yeah, so when we started, so one of the first hits you get when you're looking for BMP and the tooling around it is OpenBMP. Right, OpenBMP has been here for a long time. There's this beautiful presentation from Tim Evans on OpenBMP, which is from 9 years ago, which beautifully explains the architecture and everything around it on what they solve, right? Which is all the things we just talked about. So that seemed like a very good starting place. It is a full solution, right? So it has all the things end to end in there. So we were like, okay, well, if we quote unquote just implement this, we're good to go, right? That's the happy path. Unfortunately, that ended up not too happy, right? But from and we saw a couple of other tools. Let's get into those in a little bit. But from that perspective, we hope to just see like, okay, we have the routers. Let's open up OpenBMP, set that up end to end, and look if that will make it work for us. The beautiful thing about it is it provides an end to end solution, right? It got every building block in there, and all the building blocks. I mean, so from the router perspective, looking bottom up, so the router would push its data into the so-called collector, right? So once it's there, that is then pushed onto Kafka, a message queue. We can go into detail in a bit. That is consumed on a central side. That data is pushed into a database, right? And once it's in a database, you could essentially do anything with it. We would put an API in front of it, and then therefore other systems can use that data. So that whole architecture is what is very good about the in the OpenBMP solution. Though what we found is a couple of challenges, right? So pretty much every building block is a different language, right? So one is written in C, one is written in Java, one is written in Go. Then you got the database, of course, and we were looking at that like, okay, well, we could work with that. It's not ideal, but okay, let's give it a try. We saw that a bunch of libraries were outdated, and I started looking at that. Okay, can we update those? If we can, it might still be worthwhile. But that proved to be challenging. And with that, it's like, okay, we have to make a decision at some point, of course, on do we go with this or not? And I literally did not want OpenBMP to be my legacy in delivering a solution which has multiple languages, outdated software, and like that was not going to happen.
You didn't want OpenBMP on your gravestone?
I guess not.
Well, so OpenBMP, you explained some of the shortcomings of the project. Has it also been largely abandoned or left alone? You said the presentation from Tim goes back 9 years.
Yeah, and if you briefly look at it, all is fine, right? There's a Dockerized solution. There's an all-in-one Docker that you could look at and spin up and play with it, and that seems good. But I was asking questions on a platform that they refer to on the website, and I never got a reaction on that. So from that moment, I was like, okay, well, if I need to maintain this on languages that I'm not comfortable enough with, and updating and maintaining and making that my legacy, and then pushing that onto the team to maintain that eventually, because I'm self-employed. I might, or there's going to be a point in time that I will do something else, and then that's going to be my legacy. So that's not what I aimed for.
So where did you go next then?
So we looked at a couple of other open source tools. There's also a solution out there which is a managed service. We looked at that, which under the hood seems to be using the same kind of architecture. And then we're like, okay, well, do we want this do we want this as a service, or do we want to manage it ourselves? A lot of stuff we do at this company is managed ourselves. So there is enough experience to do it ourselves. So that was one of the decisions. Okay, let's either we do it ourselves, or it might we could fall back to a different party, but that looked like the same solution under the hood. So there's a tool called PMACCT, which does a whole bunch of things on monitoring and net flow, but also has a BMP portion of it. There's Go BMP, which can also write to Kafka, but has some other or different outputs as well, as they say on GitHub. That one doesn't seem, or they say, well, it's still work in progress. So that kind of felt like, okay, maybe this is not necessarily the one for us. So we were looking and playing through each one of those tools, right? But we ended up with a open source one from Cloudflare, which is called BBMP to Kafka, which essentially is only the collector, right? So if we look back at OpenBMP, the architecture of it perfectly was a perfect match for our architecture that we have, right? We got a multitude of POPs, right? This could run on each of those. The collector could run on each of those POPs. They would connect to Kafka, throw everything in there centrally. We would consume it and put it into a database, along with the API being present centrally. And because of that architecture being a perfect fit, we were specifically looking for the same kind of thing, but then maintained, right? Or at least something that we could work with. So as I said, BBMP to Kafka was the solution, or the open source tool that we saw and that we went with.
And again, you liked it because it had the architecture that you felt you could work with. What about the language? Because you mentioned it sounded like you'd be doing some of the software development around this, or handing it off to people to do development.
Yes. So this is written in Go. It's not my primary language, right? I've started with Python. Well, back in the days, Bash, but you cannot get very far with that. But so Python most of the years. I did a little bit of Go, but given or assuming at the start that there was a lot of data coming that would go through it, right? So Go seemed like a better choice for deploying that service on, right? And this had it. So the collector was, with this tool, being pretty much done, right? So on top of that, we have on the other side of Kafka, if you will, there's the consumer. That was something that we needed to write ourselves. So that's what I did also in Go, because to match both sides and making the entire solution one language, right? Up till the database, that's one language. So we settled on Go for that.
Sorry, what is the consumer? Because so we've got routers. Routers are sending routing data to a collector. Then what happens?
Yes. So the collector takes that data, essentially puts it into a protobuf, pushes it onto Kafka. And on the remote side, right, on the consumer side, so the collector is the so-called, in Kafka you talk about producers and consumers. So the collector is producing data into Kafka. The consumer on the remote side is consuming Kafka.
Okay.
And puts it into the database.
Okay. And then in the end, the client is basically looking for information that would be in the consumer that had come from the router via the collector.
Once it's stored in the database, you could essentially do everything with it, right? So we chose to have an API in front of it, so we could control the narrative on that. We were able to choose which fields to expose or to make it a fit for the client, essentially. But that's an API that essentially queries the database. That API is just an API gateway in AWS running a Lambda on demand.
So then Kafka is the other missing piece, I think, for a lot of folks who haven't built a system that involves Kafka. It feels like a needless middleman. It's like, wait, I've got collectors in the front and consumers in the back and Kafka in the middle. Why don't I just take data from my collectors and dump it in a database and then query the database? What's Kafka doing for me?
Yeah, so Kafka gives you the benefit of being this transparent bus in between, right? And it allows you to not have a point-to-point session between a client and a service, right? But you can have multiple producers, multiple clients dumping their data into that big message bus. And consume it on the other side. But because that message bus is in between, there's memory, there's storage to it, there is no coupling between the producer and the consumer. They can be standalone. And even if the consumer is busy or not available at a moment, there's a certain retention time to that data that is just stored in that message bus. So because they're no longer coupled, you have the benefit of just dumping it, get it out of the way, and it's no longer on the POP. It's just now in the on the bus, in the cloud. It's somewhere.
A bunch of messages sitting there. As a consumer, I can get it when I'm ready to get it, and Kafka will buffer it for me if I can't get it as fast as maybe it's being sent in a given moment. And I assume I could have a bunch of different consumers, so I could have a bunch of different systems that want to subscribe to Kafka and pull data out of that if I wanted.
Yeah, so you could have a group of consumers, right? Which is in our case, and since they are part of a defined group, they will work together and they would not take the same message also, right? So there's a certain intelligence to it that if one consumer takes it, the other one will not, and it might take. They will load balance some of that, right? A side benefit, if you want to, if you have a more complex situation, is where you could have another service that is using the same data separately from the service that we were working on. So they could also use that data just separate of ours, and there would not be any conflict between services. They have no interaction with this. They just quote unquote tie into the message bus and consume that data for themselves.
Okay, so I think we got a better idea of what Kafka is doing in this scenario. Now, I did a bunch of reading on this and tried to get a sense of it before the recording. You made it even more clear, for me. But my world was old school, smaller scale. SQL databases were fine. It was enough, and we liked it. We didn't need no Kafka. But But then digging in, part of the problem that Kafka is addressing is volume and scale and speed and massive amounts of records and messages being flung around. Kafka can handle all that. That seems to be what it's designed for. Whereas it can be pretty easy to overwhelm a database, depending on what the hardware platform is and how much you're throwing at it and so on. Kafka can be that buffer in the middle that handles all of this. And even with Kafka, Bart, I know you still ran into scaling challenges because you guys in the ISP environment were dealing with full internet routing tables and millions of records. So walk us through the scaling challenge that you ran into.
Yeah, I did not see that coming initially, that was that many, right? And that many. But I love this expression. You know what they say, right? If we have numbers, let's talk numbers. If we have opinions, let's go with mine. But since we got numbers, let's go with that. So with the initial stuff, all the building blocks in place, right? We would have initially build like an MVP, right? In agile terms, we would have all of this in place. We could connect a router all the way through. It would dump its BGP data into the collector that goes into Kafka, that goes into the consumer in the database, and then we could see how it reacts and see information through that or with all that data. So that's what we had at a certain point. And some of the things like the Kafka, we already had some Prometheus and Grafana monitoring on it, and we noticed that we just had a very, very low throughput, and we were talking about 30 messages per second, right? So that was okay. New task: add more monitoring to the collector and see what's going on, right? Is it the router that's not pushing quick enough? Is it the collector that is having a hard time pushing it into Kafka, or where's the fault at hand? And so, long story short, with the monitoring in place, we noticed that we were pushing to Kafka, and Kafka was, or the interaction between the collector and Kafka was the bottleneck, and we were just pushing messages at 30 messages per second. So
Which doesn't sound like a lot
right?
If we're talking about routing records.
No, so maybe it's good to go one step back, right? If we look at the prefixes, right? What do you get if you connect an ISP to a router? You will get around 950,000 these days, the Internet Routing Table of IPv4 records. Then you get another 200,000 for IPv6 if you connect that as well. Being a regular ISP, you get or a service provider, you get a couple of those, right? So you get a couple of ISPs, then you get a couple or dozens of IX pairs, right? And you get all of those. Then you got on top of that your customers, of course, and since you have multiple POPs, they all interconnect in one way or another, right? Either they have, which is not a full mesh, but still there are certain POPs acting as quote unquote super POPs, right? And they would have a lot of connections, being the reflectors that we talked about previously. So if you look at such a POP, right, you got a multitude of connections, multitude of prefixes coming in, and pretty much all of that is times 2, right? Remember the monitoring on the pre-policy and the post-policy. So we did some calculations on that, and on the initial dump, you would get around 20 million prefixes that you needed to process. And processing that at 30 messages per second is not good. So that posed a small challenge, right? So you do what an engineer do, right? You dive into the code and you try to figure out, okay, what can we do about this?
You think this was a code problem? I was waiting for you to tell me about some kind of a hardware problem. This is a code thing.
No, so we figured out it's not the router. So during some testing, we just disabled the pushing to Kafka and just see, okay, what are the stats telling us, right, on Grafana, and how much prefixes are we seeing coming into the collector, right? And that just went high speed. That was 100K per second, no problem, just
Okay.
full speed. But we did notice that pushing to Kafka was the challenge, right? And
so from the collector to Kafka, there was an issue.
yes, indeed. So we looked at, okay, how does that work inside Kafka, right? You got there three choices, to either being very, very strict and making sure that every message is acknowledged correctly on the application level, or as a little bit lower level, that one broker acceptance is enough and acknowledgement, or that you would just do TCP acknowledgement and you would throw more at it at the same time, which improved, but not enough. So I was looking, and this was a single session to Kafka, right? So I kind of rebuilt part of that application that we used, and we now have a group of producers, right? And essentially the fine line was having as much producers as we got CPUs assigned to that service. So we were able to bump that from 30 messages to 45K, right? 45,000 messages per second. And therefore, doing 18-20 million would give us a convergence time of 10 minutes, which on an initial dump is fine, right? Because once you have that, there's not every peer is continuously sending BGP updates, right?
Right.
So from that perspective, okay, that was one challenge solved. But still, having that on a single POP or single router, single collector, and everything is redundant, so you get it on top of the initial ×2, you get another ×2 because you got two collectors, because you got two routers, and you have some redundancy in there. You also have around 60 POPs, right? And if all of those continuously send a large amount of data centrally, you got a gigantic bottleneck, right? Where everything there comes together on the consumer side, so after Kafka. And that's where we saw or foresaw a huge problem, right? We had this enabled at 2 POPs at one point, and we were already hitting 45 million records in Postgres on the database. And we just foresaw, like, okay, if we're continuing on this with all of the data on every POP, this is going to blow up something, right? We don't know which one, but it's either the consumer, which is going to have a challenge, the Postgres database is going to have a challenge on those millions and millions of records, or the reading of that data is going to be terrible, right? On responsiveness. So we saw challenges, right? And that was an understatement at that point. So we had to look at, okay, what back to the drawing board essentially, and really go back. Okay, what is it that we actually need, right? Do we need all of that? Where does it all coming from, right? And even though ISP information might be interesting to see what's going on, and you might see some stuff happening on the internet, and where potential route leaks are, or things changing, that might all be interesting. It was not the use case for us, right?
As in, you don't need to see every prefix coming through the POPs.
For the ISPs, indeed, because essentially what we were really interested in was the customers, right? So if we could eliminate the ISPs, the IXs, but also internal traffic through the mesh, our internal data, if we could eliminate all of that, then we would be in a better place, right? And so that's exactly what we did. So on the router, on the pre and post policy monitoring of BMP, there's nothing to tune on, right? So we couldn't do it on the router itself. So going at the next best, one step higher, we would hit the collector, right? So in the collector, we modified the code and applied some filtering where we could say, okay, well, if it's from certain IPs or certain logic within that, we would just have the simple if-else statements on seeing, hey, is this interesting? Yes or no. And if it's interesting, we're going to push it onwards to Kafka. If it's not interesting, we'll just leave it at that, right? We made it a little bit more complex on that one to be able to still see, okay, well, yes, I'm only forwarding information from the customers onto Kafka and process it onwards. But also we wanted to see, okay, the other stuff might still be interesting for Prometheus and Grafana, just to have stats on those and being able to see what's going on. So even though we're not processing that anymore, we're still showing that in Prometheus and Grafana just to be able to see what's happening from your from either the internet or from the mesh and what's coming in, and are there flaps on the peers, etc. So we could still use additional information around it, even though we're not processing all the prefixes anymore, which brought us back to thousands instead of millions.
So you essentially built filtering rules in the collector. So it was getting sort of everything from the router. It hits the collector, runs through a set of filtering rules so that you're then sending less through Kafka to the consumer, and then down the chain, it's, you've reduced
everything
the
down the chain would be less, right? So we got thousands now prefixes
instead of millions.
Instead of millions on a per pop basis, right? So centrally, it could still be a high number, but not as high as millions and trillions that we were gonna hit initially.
Does the BMP protocol, I guess it supports the inclusion of filters, or is this something you had to sort of code up yourself within this open source BMP instance that you're using?
So on the collector, I coded it myself. There was no filtering in place, though. And you would, in this case, just before pushing it to Kafka, we would check on the interesting or not logic, saying, okay, well, this is interesting, push it out. If not, then there are some distinct rules around the Prometheus and having the metrics in there. But the most important part was not overload Kafka and the systems onwards.
Did you have to tweak the size of your collectors then to start engaging these filters? Did that have a performance impact there on the collectors?
No, this is it's written in Go. It's so snappy. We did not have any issues with that. If anything, we are able to actually lower the resources on that because we now are processing far less data.
Now you mentioned you were still sending, you were sending data also to Prometheus and Grafana that might not be interesting from your customer prefix use case perspective, but might be interesting from more of a global internet perspective for you as an ISP. So was that data still passing through Kafka in some way, or were you aggregating the data and sending stats off? How was that data getting over to Prometheus and Grafana?
Yeah, so that is not going through Kafka, right? So that's a separate process where we already have the Prometheus scrapers on each pop, right? So that's scraping already different systems. So this is just one additional endpoint that it's scraping.
Okay. So how do you handle situations where customers, I've been one of your customers. What happens when an idiot like me forgets to do his outbound BGP filter and is sending you an entire internet routing table? Can you cope with that situation? Because I mean, I guess you get your own policies, but how does it impact BMP?
Well, yeah, we've all been there, right? At one point or another, we've all done something that looks like that and blew up somebody.
I've done it once, and I got a call from someone that actually knew me, and he's like, "Dude, you're sending me everything. Would you stop?" What do you mean? Yeah. Dude, I wrote the prefix list to filter, and I never applied it to the interface. My bad. He's like, "Yeah, could you fix that? Thank you."
Yeah. So, and that happens, right? And I would say normally every provider out there has their own filters on their side as well, right? I mean, we all trust each other to the front door. So I guess whenever they send the prefixes on the normal service, regardless of BMP, right, there would already be a policy in there to make sure that only the parts that we were agreed on were coming through, only the prefixes that were meant to be are accepted. So now with BMP, right, we see everything post-policy, but also pre-policy because we wanted that. And yes, so it actually happened during my tests and see everything was working. I saw a database that was just higher than I expected, and I saw one specific peer with more entries than I was expecting, right? So indeed, we saw again, and now with this data, we got the timestamps and everything to prove and show for it. And we saw actually that somebody forgot to put on a filter on their side, and we were getting the internet routing table on the pre-policy. Is that a problem? No, not anymore, right? I mean, we're talking now on thousands of entries on every pop. If there's somebody that accidentally leaks a routing table, sure, you get 1 million entries. But those are not as much as we had previously. And if that takes a bit of time on the processing part, that's no biggie as well, right? There's a certain real-time factor to it, but if that takes a second or two, we're fine. The second challenge to that, once you have that in the database, how do you get it out, right? Without manually doing that, because once that remote peer enables that filter on it, you're not getting the BGP withdraws anymore. So they are not marked as not announced anymore in the database. So you have some lingering data around that was used or was pushed at one time or was advertised at one time, where it's still marked as announced, where timers are not being updated anymore because we're not getting BGP updates from that peer anymore because they actually applied the filter. So over time, talking about long periods of time, like you can have those checks and clean up scripts around that on your database where you could check on timestamps and things to ensure that it gets a little bit tidy again. But you cannot do that the next day because then the logic around it is either too complex or it doesn't find it, or you delete actually correct data, right? So you have to be careful with that and kind of accept that as part of the solution that, you might store some data for a longer period of time that isn't necessarily relevant anymore.
So you ended up coding, but you're really a network engineer, even though you're an automation-oriented person. I mean, I don't think you would consider yourself a developer first, more of a network engineer first. Is that fair to say?
These days it's tipping. There's a tipping point, right? But yeah, I've been longer in networking than I have been in coding, though I do love it, right? And I've done a lot of Python, right? And Go is the new kid on the block that I've worked with a little bit before. But I definitely went on a deep dive with this project.
So how hard was it for you to transition from Python to Go?
Well, they say it easy, but I had really the mind bending on how it's different between Go and Python on certain aspects is just, that took me a while just to get my head around, like, okay, well, yes, I'm reading this, and sure, the syntax is a bit different, but the inner things on how it's written differently, and especially if you get into channels and the Go routines and things, if you look at that versus how you would address the same situation in Python, that can still mix my head up and become blurry.
Well, you spend a lot of time in this system. You know it really well now from a developer perspective. You actually know the code and understand this whole system end to end that you built. for this ISP that you've been working with. Okay, so for listeners who want to build their own robust BMP solution, do you have some key recommendations, lessons learned?
Yeah, I guess I mentioned it already, right? Define what you actually need, right? And be very, I would say, be very strict on what you actually need, and to not overload yourself, right? Do you actually need the pre-policy data, right? Is that really part of your use case? Because yeah, you have to deal with the route leaks potentially that you get, or just a larger amount of data that you might actually need, and are you ready to cope with all of that throughout your entire solution, right? Throughout all of the building blocks that are depending on that. So yeah, and end result, less data makes everything easier, right? And also the AWS bill that you get at the end of the month.
Yeah. Yeah, I don't remember if we talked about that, but I know part of this solution is hosted on AWS, EKS on AWS, right?
So yeah, so it has several things. So the consumer is on EKS, that's on the Kubernetes cluster indeed. Then we got the database, which is actually a Postgres lookalike, right, with the Aurora solution of AWS and RDS. The API gateway is the API gateway service with the Lambda underneath that is called on demand. So there's a few building blocks of AWS in there indeed.
Well, but to the point, if that's the solution that that you might be out there listening and you want to deploy it on cloud, then of course you really want to be as efficient as possible so you're not racking up that bill. Yeah.
Yeah, so yeah, that's the first one, right? And I guess if you want to go and you need all of the data, or you want to use that either from a fun perspective, or you actually really need it for your use case, right? Prepare for the big data, because you're going to see a lot, right? And then you might want to double check, is that actually, do you actually have a real-time requirement on that, or can you use some kind of a snowflake solution that it might not be there real time, and you can have some steps in between to process all of that big data if you really need to go huge, right? And don't go at it alone, right? There's so much. I spend most of this time on this project by myself, but I was fortunate enough to be able to reach out to other people on more experience with either the database or on Kafka or Kubernetes, and getting things deployed there, right? So don't go head on alone on such a big project, right? That's an important part.
If folks have listened to this and thought, oh, maybe there's something I could do with BMP, but I want to play with it first. We mentioned OpenBMP is sort of one of the open source projects. Do you think that's a good place to start, or where would you recommend they sort of dip into this?
Yeah, so I guess from a learning/curiosity perspective, OpenBMP could be of interest, right? But if you think of making a step afterwards and actually going to use it, then OpenBMP, since it doesn't seem to be maintained anymore, you have to ask yourself the question: do you want to spend time on that specifically? If you so the Go BMP that I mentioned, which they say is a work in progress, has the benefit of not having the dependency on Kafka per se. You can have different outputs. You can show that in different ways. So that might be a small step in just having such a collector and being able to show your data that comes in a way that you're more familiar with if you don't know Kafka and don't want to build an end-to-end thing per se and just want to start small. Then that could be that could be something, right? Though having a Kafka and then essentially building two Dockers in there isn't per se the hardest part of it. But if you've never touched it, it's you're gonna have some learning hours to go to.
Well, Bart, great conversation. I love what you built. Thank you for sharing what BMP is and then the solution that you built with it. And if people got follow-up questions, if they want to know more about this, dig in a little bit with you, how do they get a hold of you?
Yeah, I guess LinkedIn is the easiest. I'm the most active on that.
Okay, LinkedIn. Yep. And of course, Drew and I are on LinkedIn as well. And as I said at the top of the show, we're on Blue Sky now too. So we'll have links for Bart's LinkedIn, along with the video he mentioned where Tim Evans covers OpenBMP, and links to the other projects that Bart is using in this project, GoBMP, BBMP to Kafka, the Cloudflare project. That'll all be at packetpushers.net. Just look for the show notes for this episode, and thank you for listening today. This has been Heavy Networking from the Packet Pushers. And by the way, if you're new to Packet Pushers, would you take a few minutes and poke around at packetpushers.net? It's not just a site that catalogs the podcast episodes. If you thought, oh, it's probably all it is. No, there's a lot more there. I mean, we do have the podcast. We do include transcripts, but that site, packetpushers.net, connects you to all the resources that we share for you for free. That includes 11 other podcasts in our network. Aside from this one, there's 2 newsletters. There's our Slack and IRC channels, our technical blog covering industry news and engineering topics, our video library, and our merch store. And don't overlook the search bar at the top of every page, because if you're doing research on a particular topic or a vendor, you can use that search function to find every podcast and article where whatever your topic is comes up. The way we built the site, it's clean, it's easy. It's easy to read. There's no popovers nagging you to sign up for things. There's no inline ads or banner ads or sidebar ads. There's no pagination that we invented needlessly so that we can serve you up more ads. If the content is sponsored, because we do have some sponsored content on the site, it is clearly marked. Now, if you got some value out of our chat with Bart and his adventures in BMP, be sure to thank him on LinkedIn. And if you've got your own project you'd like to talk about on a future Packet Pushers episode, or just have something to tell us, you can send us a follow-up at packetpushers.net/follow-up. And until our next Heavy Networking episode, just remember, too much networking would never be enough.